In this lecture, we are going to speak about the introduction of or introduction to functions. In which that we are going to define the function, speak about the domain, range of the function, and how to graph or evaluate a given function. Starting with the definition of a function. What is the function? A function is a set of ordered pairs. You can say it is a set of ordered pairs. In one condition that in which no two ordered pairs have the same first coordinates and different second coordinates. So we can say the function is a set of ordered pairs with no repetition in the first coordinate of these ordered pairs. No repetition at all. If we have repeated first coordinate, then we have to check the second coordinate. If they are different, then this relation is not a function, or this set of ordered pairs is not a function. To apply this definition for this example, we need to state whether the set of ordered pairs xy defines y as a function of x. We say that function is set of ordered pairs. It is x and y. X coordinate and y coordinate, where the x coordinate or x variable we call the independent variable and y is the dependent variable. So I have x coordinate and y coordinate. To state whether the given set is a function or not, we are focusing on the first coordinate only, the x coordinate. So in the first example, number 11, we need to check, is this a function or not? So I have to look at the first coordinate. I have 2, 5, -4, and 7. Since all of them are different, then we can say, yes, this is a function. So this set define y as a function of x. So we can say, this is yes. It defines y as a function of x. For the second one, I have 5, 10, 3, -2, 4, 7, 5, and 8. We need to check the first coordinates. Only the first coordinate. We can see that we have one ordered pair or two ordered pairs have the same first coordinate. Then I need to check the second coordinate. If they are different, if the first coordinate is repeated, then I have to check the second coordinate. If the second coordinate or y coordinates are different, then this is not a function. So this one, it is not a function, or it doesn't define y as a function of x. For the third one, again, we need to check the first coordinate. I have 4, 6, 5, and 4. So two ordered pairs have similar first coordinates 4 and 4. Then I need to check the second one. Second coordinate, I have 4 and 5. These are different. They are not the same. So this is not a function. Not a function. Again, let's go for the definition of the function. We said a function is a set of ordered pairs in which no two ordered pairs have the same first coordinate and different second coordinate. If the second coordinate are different with the similar first coordinate, then this is not a function. Third example, I have 2, first coordinate 3 and 7. We are looking for the first coordinate only. 2, 3, and 7. All of them are different. So this one is a function. So yes, it is a function. Next one, I have 1, 2, and 3. These are different. So it means, yes, it is a function. Even though the second coordinates are the same, but this is not important. For the definition of the function, we are looking at the first coordinate only. If all the x coordinates are different, then it is a function. If it happens to have, or two ordered pairs have the same first coordinate, then I have to check the second coordinate for these two ordered pairs. For the next example, I have minus 1/3, minus 1/4, and 1/4. All of these are different. So this means, yes, this is a function. Then yes, it is a function. In some other notation, sometimes we can write the relation as an equation. 2x plus 3y equal to 7. Or minus 3 plus y squared equal to 2, or y equal to 4 plus or minus square root of x. So we need to check this notation or these equations and to state whether the equation defines y as a function of x or not. If it is given in this notation, then we have to solve for y. So I need to solve for y. So the equation is 2x plus 3y equal to 7. Then I will move 2x to the other side. It will be 3y equal to 7 minus 2x divided by 3. I will have y equal to 7 minus 2x over 3. Now 7 minus 2x over 3, since the x has only the power 1, we can say this is linear function, and divide by 3 will give me one value for each value of x. Now y equal to 7 minus 2x, or I can write it as 7 over 3 minus 2 over 3x. This is linear function or linear equation. Linear equation means going up or going down depending on the slope of the line, whatever. Since I have x to the power 1, so I have for each value of x, I will have only one value of y. So we can say this one is yes, it defines y as a function of x. You can say in general, any linear function, this is linear. Means x to the power 1 will define a function of y. For the next one, I have minus 3 plus y squared equal to 2. Minus 3, this is question number 3. Minus 3 plus, what is minus 3? Sorry, it is minus x. Minus x plus y squared equal to 2. Again, we need to solve for y. I will have y squared equal to 2 plus x. Remove this to the other side. Then take the square root. I will have square root of y equal to square root of 2 plus x, or I can write it as y equal. Taking the square root of y is absolute of y, so we need to write it as plus or minus square root of 2 plus x. Because it is plus or minus, it means that I have two values of y for each value of x, or x in the domain of the function or of the relation. For example, if x equal to 1, then y will be plus or minus 2 plus 1 equal to plus or minus square root of 3. It means that I'm going to have in this relation 1 and plus square root of 3 and 1 and minus square root of 3. So we will have two ordered pairs with the similar first coordinate, but the second coordinates are different. Since I have a plus or minus again, it means I'm going to have for each value of x or in the x in the domain of the function, we'll have two values of y, which means this is not a function. I have two values with similar first coordinate. So it is not does not define y as a function of x. For the third one, I have x equal to 4 plus or minus the square root of x. Question number 5. We have y equal to 4 plus or minus the square root of x. Since we have this one, plus or minus, means we are going to have two values of y, not one. For any value of x, or any x greater than or equal to 0, I will have two values for y. For example, if x equal to 4, for example, or 9, then y is equal to 4 plus or minus the square root of 4. That will be 4 plus or minus 2. So it means that if we take the positive one, this will give me now 4 plus 2 is equal to 6, and 4 minus 2 equal to 2. So we are going to have two ordered pair, 4 and 6. And the second one is, because we chose x to be 4, this 4 and 2. So this plus or minus will give me two values of y, not one. So in this case, I have two ordered pair with the similar first coordinate, but the second coordinates are not the same, they are different. So two ordered pair with repeated x coordinate, but different y coordinate. This is not a function, or you can say it doesn't define y as a function of x. So the idea for the definition of a function to be all the set of ordered pairs or the set of the ordered pairs have different x coordinates. Different x coordinate. If two ordered pairs have similar x coordinate, then we need to check the y coordinate. If they are the same, similar, then it's okay. If the y coordinates are different, but the first coordinates are the same, then this is not a function.